Welcome to the London Christian High YouTube channel. Today, we are going to be learning about Hess's Law. Hess's Law is a process of using multiple thermochemical equations to obtain the enthalpy change, delta H, of a target reaction. The first step for a Hess's Law question is to identify your target reaction. You can see in this question, I highlighted it. In the second step, you'll need to identify similarities between the target reaction and the thermochemical equations. You can see that I highlighted all of the molecules that are similar to those in the target reaction. Carbon solid, H2 gas, and CH4 gas. Once you've determined the similarities with the target, multiply, divide, or flip the equations so that the similar molecules have the same mole amount and are on the same side of the equation as the molecules in the target reaction. You can see I kept equation A the same, so we have carbon solid on the left. I multiplied equation B by 2, so we'd have 2H2G on the left, and I flipped equation C, so we'd have CH4 gas on the right. Once you've made any necessary changes to the equations, scratch out all of the molecules that aren't included in the target reaction. Molecules on opposite sides of the equations will cancel each other out. Here's an example of how this works. So note here, the two O2 molecules on the left will cancel out the 2O2 molecule on the right. The CO2 gases will cancel each other out, and as will the H2Os. Now, we are left with only the target reaction. The fifth step is to apply any changes you've made to an equation to their delta H value. For example, if an equation were flipped, you would flip the sign of the delta H value. If you were to multiply an equation by 2, you would multiply that equation's delta H value by 2. If you were to divide an equation by 3, you would divide that equation's delta H value by 3. Once all of these steps are complete, all you have to do is find the enthalpy change of the target reaction. Enthalpy change for the target reaction is the sum of all enthalpy change, delta H values of the thermochemical equations. Here's the formula. Please pause this video and give this question a try. So, here's the solution. Basically, we started by looking for similarities between the target reaction and the given equations. We found similarities in each one, but only equation B needed to be changed, so that we had MgO solid on the right side of the equation. Next, we scratched everything out that needed to be scratched out, and then determined the enthalpy change of the target reaction. We got a final answer of negative 613.95 kilojoules per mole. One thing to note is that you don't always need to use all of the thermochemical equations. If there's a molecule that doesn't match up with the target reaction and can't be scratched out, don't use this equation. Here's an example. In this question, we noticed that there were no plain O molecules anywhere other than equation A. Because of this, we don't use equation A. The rest of the question is pretty normal until we get to scratching out. We'll start by scratching out here, but then we're left with 2O2 gas on the right and 3O2 gas on the left. What we'll do here is we'll scratch 2O2 gas from the right with 2O2 gas from the left. Therefore, we will be left with 1O2 gas on the left, as is required for the target reaction. We'll complete the rest of the question as we normally would, and we should get a final answer of 29 kilojoules per mole. I hope this video has helped improve your understanding of Hess's law. Best of luck going forward, and thanks for watching.